Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Hey guys, let's go over lesson 1.2, solving quadratic equations by graphing. What's our learning targets here at 1.20? In our Common Core standards, graph equations on coordinate axes, which is just like a coordinate plane, which is this thing down here and that I've highlighted in green, with labels and scales. And we'll also be able to sketch graphs, showing key features given a verbal description of the relationship. How can I meet the standard? I can create equations in two variables and graph these equations to determine their solutions. Let's go on to this quick idea of an introduction, how to solve quadratic functions. There are 5 ways, and we'll also talk about its graph. Hey math lovers, I just wanted to go over with you guys solving quadratics introduction here. And there's a bunch of ways of solving quadratics. You can solve it by factoring. Remember, that's our x in our box method. And it's the easiest one, but it doesn't always work. Doesn't always work. So try factoring. If you can't factor, that's okay. There's other methods. Number 2, there's a square root method. This works when b is equal to 0. So it's a very specific case. Number 3, I'm going to put some stars by this one. The quadratic formula. Okay, this one always works. Okay, it always works. It is the longest method, but it always works. Number 4, I'm going to show you guys the graph, and then number 5, completing the square. This is best when a is equal to 1. And it helps you get into the vertex form. So let's talk about this idea of graphing something. Okay, so here I have a coordinate plane here, xy Cartesian plane, and all those methods in blue there are really just to find these points right here, the blue ones. That's all the reason why you have this big blue box here, is to find these particular points. Okay, what are those points called? Well, we have a bunch of names for these points. We call these the x-intercepts, because that's where it crosses the x-axis. We also call these roots. 3, they also call these solutions. Again, we're talking about those just points right there. And then the last one is they also call these zeros, because it's an ordered pair. The x-coordinate is some kind of number, and then the y-coordinate is a 0. So introduction, the big idea, the visual is that you're just finding these points right there. See you guys. All right, so let's go over a warm-up. It says to find the x-intercept of each function. Remember, the x-intercept is where it crosses the x-axis. And so very specifically for, like, say, question number 1, it crosses the x-axis, this graph does, in 2 locations. That first one is x equals 2, and over here it is x equals -4. So we would say that this graph has 2 real solutions. X equals -4 and x equals 2. What does it mean to be real? It just basically means that it crosses the x-axis. Let's take a look at number 2. Same thing. This is a graph that is opens down or concaves down. It's like a cup turned upside down. And again, you have 2 solutions here. And because it goes to the x-axis, we can say 2 real solutions. zoom in here. So that would be x equals -1 and x equals +4. Same thing over here. Question number 3, you have crosses the x-axis, so you have 2 real solutions. That would be x equals -3 and x equals 0. Just a quick note about these x-intercepts. If you have an order pair, so that's the origin 0, 0, and this one would be a x equal, that order pair would be -3, 0, right? X, y. And so I want to point out there that an x-intercept will have a y-coordinate of 0, always. Always. So y-coordinate is equal to 0 when you have an x-intercept. And same thing for this one over here. We have 2 solutions, 2 real solutions. You have it at x equals -1 and x equals +1. Okay, let's look at number 5. I put this graph in there. Let's go ahead and add some arrows there. And my question is, does it touch the x-axis? It does not. So we can do a couple things here. We can say there are no real. No means that there are none or 0 real solutions. And what we're going to learn later on is that we're going to have something called complex solutions. Okay. And let's draw number 6. Let's say this is 1, and let's just say my graph looks like this. Now, although it's only touching the graph once, we're going to learn later on in the fundamental theorem of algebra that because it's quadratic, let me write a quadratic here, there basically has to be 2 solutions. 2, in this case we have 2 real solutions, but it only touches the graph once. But basically what happens is there's my 2 answers. I don't know if that makes sense. This is my first answer, x equals 1, and my second answer is also x equals 1. We also call those double roots. So x equals 1 and x equals 1. And super fancy is we're going to call this later on in the next module. We're going to say x equals 1 with a multiplicity of 2. Multiplicity of 2. Let's just repeat it twice. Okay? All right, let's take you out to the ball game.
The fans of the Wildcats basketball team are less than excited when the halftime buzzer sounds. Suddenly, the mood changes and everyone is on their feet cheering loudly as the mascot makes his way onto the court. To get the fans excited about the game, the mascot brings out a t-shirt launcher to blast team shirts into the crowd, and the fans go wild. The path of each shirt as it makes its way into the hands of one lucky fan can be modeled by a parabola. A related quadratic equation could even be used to determine where each t-shirt will land in the stands. Maybe that will help your chances of catching a shirt next time you attend a game.
All right, so Lily is at a basketball game. The mascot launches t-shirts into the stands, and each prize can be modeled by a parabola. And Lily can write and solve quadratic functions to determine each prize will land, where the prize will land. All right, let's take a look at some vocab words here. A function with the equation of the form y equals ax squared plus bx plus c, where a is not equal to 0 and a, b, and c are integers. This is called a standard form. Of a quadratic equation. Standard form of a quadratic equation. Just want to talk about that really quickly. Simply, how do you know it's a quadratic equation? It's going to have the power of 2. Now later on that might be x times x still equals x squared. But that gives it away that it's to the power of 2. Standard form has the letters a, b, and c in it. Standard form is a, b, and c. Okay, an equation. So let's do this next part. Let's do it with purple. An equation. That's an equation, right? Equal sign. That includes a quadratic expression. A quadratic expression. So the quadratic expression is kind of like, I guess I should, let's see, I can change the color of that. The quadratic equation is this part right here. Sorry, expression. ax squared plus bx plus c. So an expression just basically means that there is no equal sign, but if you put an equal sign in front of it, that's an equation, and then you can change it to your favorite, such as y equals or f of x. You know, if it's y equals, that's an equation. And if you do f of x, those are called functions, functions for f. And so that whole thing is just called a, if I put this all together, this would be called a quadratic equation. Okay, let's go on to 1.21, one real solution. Okay, so there are some steps here. Steps to solving quadratics by graphing. Let's go over these steps. Step number 1, set equal to 0. If you want to put a slash through it. Set equal to 0. So over here it says 10 minus x squared equals 4x plus 14. I like to draw a line down where my equal sign is. And what we're going to try to do here is move all of this across the green line. In order to move it across, we're going to have to use our properties of equality. So to set equal to 0, I'm going to add x squared. And we can also, opposite of positive 10 is to subtract 10. And I'll put it underneath here. Because I realized that they're what? Like terms. Okay, so 10 minus 10 equals 0. Negative x squared plus x squared, or negative, whoops, sorry about that. Negative 1 plus a positive 1, so those are the numbers in front. That's also going to equal a 0. So we have on this left side 0 equals, I have 4x, positive 14 minus 10 is positive 4 plus x squared. And we'll write this in descending order so it's in standard form. So I'll have x squared plus 4x plus 4. Okay, so now we have a quadratic equation set equal to 0. The second thing I'm going to do is I'm going to find the axis of symmetry. Find axis of symmetry. And if you pull out your formula sheet, which is just a piece of paper that you write down like maybe one formula for each lesson, is there is a formula. And that is x equals negative b over 2a. So remember, standard form is the a, b's, and c's. If there's no number here, it's either 1 or 0. In this case, it has to be 1. B is 4. And c is positive 4. Just the numbers in front, they're called coefficients. Okay, so b is 4. A is 1. So x equals negative, and that one has a 2 in front. So that would be x equals negative 4 over 2. 4 divided by 2 is 2, so that'll be x equals negative 2. Let's use a color here. How about green? Okay, so right there we have found our axis of symmetry. Okay, step number 3. So this is number 1. This is number 2. And number 3 now is we're going to make a table of values. Table of values. So here is my table of values. We did this in lesson 1.1. And let's go ahead. I just found something really cool. So cheesy. If I hold down the line, it makes it straight. I know. Not cool for you, but so cool for me as a teacher. And I got to get in 5 points in here. I didn't do it that time, but so I need 1, 2, 3. I'm going to use this gray one right here, 4, 5. And this is the reason why I have this green one. The green one has to go in the middle right here. This is why we do the axis of symmetry. That is our negative 2. So this is our x value. This is my function. This is where I'm going to put my work. F of x equals x squared plus 4x plus 4. And this is the order pair of my solutions. X comma f of x, or x comma y. And the axis of symmetry there, highlighted in green, x equals negative 2, is so important because it tells me values to pick. It tells me what to pick. It is in the middle of my parabola. Remember, you folding the taco, the parabola, on the axis of symmetry. So go up by 1 and down by 1. And basically what I'm going to do is I'm going to take that value, all these x values right here, and we're going to put in for every x value. Okay? Let's go ahead and do that. So I have f of negative 4, so I'm using function notation, it's just a way of showing my work. Negative 4 squared plus 4 times negative 4 plus 4. Remember, every substitution is in parentheses, and we're going to use PEMDAS. If you need to, you can just write PEMDAS. We go on those chunks left to right. Negative 4 squared is 16. 4 times negative 4, remember it's a multiplication here, not 4 minus 4, so it'll be minus 16 plus 4. And 16 minus 16 is 0, so my answer is 4. When I put into my function negative 4, I get a positive 4. Okay, let's try negative 3 now. If I put in negative 3 here, negative 3 squared is 9. 4 times negative 3 is negative 12 plus 4, so I get 9 minus 12 is negative 3, and negative 3 plus 4 is positive 1 is my answer. When my input is negative 3, my output or answer is 1. Let's do negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. And that's positive 4. So 4 minus 8 is negative 4. Negative 4 plus 4 is 0. So when I put in negative 2, my answer is 0. Negative 1. Negative 1 squared is 1. 4 times negative 1 is negative 4 plus 4. Negative 4 plus 4 is 0, so I'm left with an answer of 1. I don't know if you've catched that pattern, but if you do what I kind of told you about, you'll see that my green solutions have the same answer. And what do you think this next one, as I do it in blue, what do you think the answer is going to be? So let's put in 0, 0 squared, plus 4 times 0 plus 4. So 0 squared is 0, 4 times 0 is 0, plus 4, 0 plus 4 gives me 4. So if I put in 0, I get 4, and above we had -1, 1. Okay, so that is our table of values. All right, next we need to graph it. Graph. Let's graph this. It's like a game changer. It's the ruler. All right. Now, if I was wise, I would have realized that I should just go over here because we're all more on the negative side. And let's just put some tick marks up here, try to do equally spaced. And you don't need, and as you're drawing your tick marks, do not like put every single number, but you do need to put like something like that, minimum. Okay, let's graph this. -4, 4, so left 4 on the x-axis. 1, 2, 3, 4. And then up 4 on the y-axis. There is my point. Should have given you guys some graph paper, but I forgot. -3, 1, maybe we'll do it. Make the video. Left 3, up 1. Okay, the vertex, -2, 0, left 2, dang it, sorry. Left 2, stay, or 0 on the y-axis. And left 1, up 1 from the origin. And starting at the origin, we're going to go stay on the x-axis, 0, and then 4 on the y-axis, so up here. And let's go through. Okay, so that is step number 4. That's how to graph it. Okay, step number 5 down. We need to find the solutions. Find solutions. Just like the warm-up, well, how many times does this graph cross the x-axis? Well, it does it right here. That is my solution. So we can say that we have a 0 or solution of x equals -2. If you put in -2 into our equation up there, you will basically get 0. And basically we're kind of saying, remember the big idea here is that where it crosses the x-axis is our solution. Okay, let's try the questions below. For questions 1 to 3, skip one problem and use the related graph of each equation to determine its solutions. So let's go over here now. Question number 1. Remember, we talked about how, let's just highlight it, solutions are where it crosses the x-axis. Okay, where it crosses the x-axis. So for question number 1, does it cross the x-axis? The answer is none, or no real solution. So again, if you say 0 times, we're saying that means none. Do you want a sandwich right now? No, I want 0 sandwiches, if that makes sense. Okay, question number 2, where does it cross? So kind of easy, they're giving us the graph. Then we have our solutions at x equals -2 and x equals 5 is our solutions. Now some people will do something like this. They'll write -2, 5, and I don't like that because students think that is an ordered pair, but it's not an ordered pair. The ordered pair would be negative 2 comma 0, and 5 comma 0. And question number 3, we have it here, so that would be x equals negative 4. Now, we talked about before in the intro video that the warm-up is that it's a double solution. So essentially you would write something like x equals negative 4. So it sounds weird to write it twice, but that actually might give you some hints later on when we talk about polynomials. All right, question number 4, directions. For questions 4 to 6, skip one problem and solve each equation by graphing. All right, let's look at question number 4. I'm going to use my 5 steps above here. Okay, set it equal to 0, find axis of symmetry, table of values, graph it, and find the solutions. All right, it's already set equal to 0, done. Vertex, so A equals 1, B equals negative 10, and C equals 21. Step. The next step is I'm going to find my axis of symmetry. So x equals negative b over 2a. My b value is negative 10. Let's put that in parentheses. And then 2 times my a value, which is 1. So you get x equals opposite of negative 10 over 2. Here in green, that becomes negative 5. So I have the opposite of negative 5, which is positive 5. There we found the axis of symmetry. So let's go ahead and make our table of values. X, my function, and then my order pair, x comma y or x comma f of x. And one, two, three, four, 5. And again, this one is so important, it has to go in the middle. Whoops, can't. So there's 2 above it, and I guess I don't need this one. Just goes there and there. Okay. So 5 goes here. Switch that. If 5 goes in there, then you just need numbers that go above or below it. So that would be 6 and 7, and 4 and 3. Okay, so let's go ahead and just substitute those in there. 7 squared. So this would give me 49 minus 70 plus 21. Negative 21 plus 21 gives me what? 0. So 7 comma 0 is my answer. Remember, your answer goes on the right side, which is kind of like the y or f of x, the output. Okay, if I put in a 6 here, feel free to use a calculator. You're going to get 36 minus 60. That would give me negative 24, and negative 24 plus 21 would give me negative 3. So when I have 6, I have negative 3. Let's put in 5. 25 minus 50 plus 2. So that would be negative 25 plus 2 would give me a whoops, you gotta pay attention. Negative 25 plus 21 gives me a negative 4. And let's go back to blue. 4 squared minus 10 times 4 plus 21. I get 16 minus 40 plus 21. So that gives me negative 24 plus 21 gives me negative 3. 4 comma negative 3. And then our last one, just putting in there 3. So let's put in 3 for every x value. So I have 3 squared, which is 9, minus negative 10 times 3 is negative 30. So left to right, 9 minus 30 is negative 21, and negative 21 plus 21 is 0. 3, comma 0 is my answer. Okay, let's go ahead and graph these. Looks like I'm staying on the right side. No, sorry, all positives. So right side, 1, 2, 3, 4. 5, 6, 7. And looks like we're going below 1, 2, 3, 4. Okay, so let's go ahead and graph these. So I have my purple pencil, 7, 0, right 7, stay. Right 6, down 3. Right 5, down 4. Right 4, down 3. And then right 3 and stay. Right 3 and stay. So this is what my parabola looks like. Didn't like that. Haha, mine's better. And remember, I'm just gonna x equals negative 5. The axis of symmetry that we highlighted here in green. Look at this. It's meant to fold that parabola in half. And what are our two solutions? We have two real solutions. X equals 3, because that's where it crosses the x-axis, and x equals 7. All right, question number 5, we're going to graph it. Remember, if you get stuck on setting it equal to 0, so we already set equal to 0, I'm going to find my axis of symmetry, but to do that, I'm just going to find my A, B's, and C's. There was no number there, whoops. We missed it. It's a 4. Do you see how it's in front of the x squared? So A equals 4, B equals 4, and C equals 1. Remember, our formula is x equals negative b over 2a. Always write down the formula. Fractions are always vertical. And we're just going to substitute that in there. B equals 4. And A equals 4. And I have 2 here. Okay, so x equals negative 4 over 8. And actually, the better one is actually not to. I'll tell you the mistake for students. They'll think that 4 divided by 8 is negative 2. And this is wrong. Here it is easier, I think. If you put a 1 here, this is 1 times 4. 4 divided by 4. This is what it means to cancel. You're left with x equals negative 1/2. X equals negative 1/2. Now I know you might be scared, but don't be scared. It is a fraction. And from here, if I were doing the problem, I would just kind of count negative 1/2 is between 0 and negative 1. So I would probably just choose negative 1 whole numbers. And then this one would be 0 and 1. Because the distance, it's a negative 1/2 is between negative 1 and 0. Okay, let's go ahead and graph the, let's go ahead and compute a table of values. And so this problem is 4x squared plus 4x plus 1. And so every time I see a x, we're going to put in a -2. Wow, that was messy. Plus 1. Okay, here is my -2. And let's just go ahead and simplify that. Remember, order of operations tells you to do exponents before you multiply. So -2 times -2 is positive 4. 4 times 2 is 16. 8 times -2 is -8. And that is 6 minus 8 is 8. 8 plus 1 is 9. 9 is my answer. So when x is -2, my answer is 9. Let's do the same thing for -1. Put in -1 here. -1 times -1 is 1, and 1 times 4 is 4. 4 times -1 is -4. 4 minus 4 is 0. 0 plus 1 is 1. So -1/2, and I get my answer of 1. All right, let's do the -1/2 here. Let's do different colors. So let's put in -1/2. See if I can do some side problems to help you. -1/2 squared is just -1/2 times -1/2, and negative times negative is a positive. Then we're just going to multiply the numerator and denominators. 1 times 1 is 1. 2 times 2 is 4. Okay, this one I'm going to make for a fraction. Put it over 1. You're going to do the same thing. We're going to multiply. Positive times a negative is a negative, so I'm going to change this to a negative. And then I'm going to multiply across. 4 times 1 is 4. And 2 times 1 is 2. So that will give me a -4/2 plus 1. And you'll notice the same thing over there. You're just going to multiply the numerator and denominator. That would be 4 over 4, which would give you 1. 4 divided by 2 is 2. And 1 minus 2 is -1. -1 plus 1 is 0. So I have -1/2, comma, 0. Let's go ahead and do the problem here. We're going to substitute in x equals 0. So 0 squared is 0. 0 times 4 is 0. 4 times 0 is 0, and plus 1. So 0 plus 0 plus 1 is 1. When we put in 0, the answer was 1. And the last one, 4 times something plus 4 times something plus 1, and we're going to put in x equals 1. So this gives me 1 times 1 is 1. 4 times 1 is 4. 4 times 1 is 4. And all those together, you'll get 9. 1 comma 9. Do you see the blacks are the same y answer? The blues have the same y answer as well. Let's go ahead and graph that. Okay, so it's going to get up to 9 on the y-axis. So let's just count this as 3. Okay, see that, come on. 3. Okay, I didn't want it black, but it's fine. 6, 9. And we're going to be going from -1/2. So say this is 1, -2, 1, 2, and I know my problem. Let's see. Oh, that should be okay. Okay, -2, 9, so left 2, up 9. That's this one up here. Negative 1, 1, left 1, up 1. Now pay attention. That's like 2, this is 1, so it'll be like that. Okay, here's my vertex, negative 1/2, 0. So I'm going left, negative 1/2, and staying, right? That's this one up here. And then 0, 1. So that would be right here. And then 1, 9. Right 1, up 9. And here is our, let's see how I did, let's see. Can I move this thing? Pretty good. Here's art lesson. Just make your dots way bigger. See that? Okay, so question. How many times does it go through the x-axis? Well, we have, you can say 2 real solutions at x equals negative 1/2 and x equals negative 1/2. This is one option. Or you can say 1 real solution, x equals negative 1/2. But here you have to state with a multiplicity of 2, or say it's a double root. Okay, and let's go ahead and try number 6. Let's write standard form above it. Remember, there's a 1 there. A is 1. Okay, there's a 1 there too, right? Nothing's there. It's either a 0 or 1, and if it was 0, 0 times anything would go with 0, it would go away. So it must be a 1 there. And C is negative 6. Let's write down our axis of symmetry. Always write down the formula. A is 1. B is 1. Let's write in everything else. There's my negative sign. And 2 down here. So if we simplify this, x equals negative 1/2. Fun! They gave us another fraction. But that's okay, because I put it here in the middle. And we can just do what we did in the previous problem, is we can just go up. So from there we can go negative 1, negative 2, and then 0, 1. Let's write down our problem. And we're going to go something squared plus something minus 6, and that something is negative 2. Dope. Negative 2 squared is 4, and that will give us 4 minus 2, and that'll give us 2, and then 2 minus 6 is negative 4. Let's substitute in, or every parentheses there is basically what the x is, and x in this problem is negative 1. Negative 1 squared is 1. 1 minus 1 minus 6. 1 minus 1 is 0. 0 minus 6 is negative 6. So negative 1 comma 6. Negative 6. And I have our wonderful negative 1/2 here. So there's another way. Let me show you guys. This only works for exponents. This is called the power rule. So you can distribute that exponent to its exponent. So that becomes 1 squared, which is 1. And 2 squared is 4. But notice where the 4 answer will be is in the denominator, bottom of the fraction. And negative times negative is a positive. Minus 6. And you can double this because they're equivalent fractions. So I have 1/4 minus 2 over 4 minus 6. Let's just make that one a fraction too. I'm going to put that one over 1, and we're trying to get denominators of 4. So this one will get us negative 24 over 4, right? Does that make sense? Now that they all have a common denominator, you can just subtract the numerators. 1 minus 2 is negative 1 minus 24 is negative 25. Oh yeah. Negative 25 over 4. You might be asking, what is that? You can just put in your calculator, but 4 goes into 24, how many times? 6, and there's a remainder of 1. So it is $6.25 negative. Okay, and let's do the 0. So if I put in 0 here, you'll just realize that that just is negative 6. 0, comma, negative 6, and let's put in the last one, 1. That'll be 1 plus 1 minus 6, so 2 minus 6 is negative 4. 1, comma, whoops, negative 4. I wanted that to be blue. Why? Whoop, 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 whoop. No, don't do that. Let's try that again. There it is. So that my blue answers match. All right, let's go ahead and graph this. So we're kind of right in the middle, and let's do 2, 4, 6. So we're counting by 2's on the y-axis, and that'll just be 1, 2, 1, 2. Okay, let's graph that. Left 2, down 4. Left 2, down 4. Green. Left 1, down 6. Okay, let's do this one. Left, negative 1/2 or negative 0.5, or between negative 0.5 is between 0 and negative 1. So let's just put that axis of symmetry in with this thing. So my graph's kind of go through that, if that makes sense. And then negative 6 1/4 or negative 6.25, which means just a little bit lower. So it's like right there. 0, negative 6. Stay and go down 6. And then right 1, left. Right 1, down 4. Right 1, down 4. And let's get a color you might like. Let's see how I do on my graph. Pretty good, pretty good. I liked it when it was hand drawn, because you can just connect the dots, essentially. Okay, and then what kind of solutions do we have? Now, pay attention. If you don't extend your lines, which I'm going to extend it, remember those arrows mean it goes on forever, then ours has 2 solutions. And the hard part is our solutions. We can just say 2 real solutions. Because if you look up here on our table of values, they didn't give us a fun problem here. Let me think. -3, +3, -2. Yeah, they didn't give us a great. Because you notice none of the y values are 0. None of the y values are 0. I see that for our first problem, those purple ones. And for the example, they're in black. You see it? So you can kind of estimate it. That's -3, and this is +2. So x equals 2, and x equals -3. They didn't do, again, a great job. But I did that in my hand by factoring, which is a different method we're going to do next. All right, let's go over question number 7. Let's go ahead and write the standard form right next to it. And in doing so, it helps us identify our A, B's, and C's. Remember, there is no value there, so it's a 1. So A equals 1, B equals 2, and C equals -3. Let's go ahead and find our axis of symmetry. We're just going to substitute in our values. That'd be 2. A is 1. And that'll simplify to 2 over 2, which is -1. Okay, with the axis of this must go right in the middle, always. This is the key to it because it is the axis of symmetry. So if I put in here -1, you can go -2, -3, and then 0, 1. Let's go ahead and put in our function here. And remember, every x value we're going to put in x equals -3. Let's do that. So -3, and that will give us 9 minus 6 minus 3, and 3 minus 3 equals 0. So you put in your answer over here. This is my x value, and you have an order pair -3, 0. Alright, let's go over here, do the same thing for -2. We're replacing every x value now with -2. -2 squared is 4, minus 4, minus 3. So we're going to have -3 as my answer. -2, comma, 3. Okay. Let's put in now into this function -1. This will give us 1 minus 2 minus 3. -1 minus 3 would give us -4 as our answer. So -1 comma -4 is our answer. And let's do the same thing for 0. 0 plus 0 minus 3, your answer is going to be -3. 0, comma, -3. And our last one is 1. Let's go ahead and put a 1 in there. This will get me 1 plus 2 minus 3, and that'll give me 3 minus 3, which is 0. graph this. I think we got a graph down here. It's a little bit too far, so I'm just going to do it here. And just do a couple of values here. Not the greatest graph, but -3, 0, so left 3, 0. -2, -3, so left 2, down 3. -1, 4, left 1, down 4. 0, -3. And I want to point out that this is actually your y-intercept. And why I point that out is because it's your c-value. So if you put in x equals 0, you will get this. So this, it helps you cross where the y-axis is. So it kind of just gives you kind of like another puzzle piece. And our last one, 1, 0. Let's go ahead and put a graph through this. See how we do. Not bad. Remember the trick, just make your point way really big. And how many times does this go through the x-axis? That would be 2 times. So we have here 2 real solutions. And now we got lucky because that was x equals -3 and x equals 1. And we saw that from our table of values, didn't we? All right, let's go ahead and try question number 8. This one's going to be ultra fun because you write standard form. A equals -1, B equals -6, and C equals -9. Let's go ahead and put in our axis of symmetry. So our B value is -6. A value of -1. So make sure you make that negative sign on the outside. Don't forget the 2. This will give us -6 divided by -2, which is +3, and the opposite of +3 is -3. So this one is going to become our axis of symmetry. And it always goes right here in the middle. Notice there's 2 points to the left and 2 points to the right. So here goes a -3 and go -4, -5. You want consecutive integers, which basically means numbers that are next to it. And we have negative x squared minus 6x minus 9. Okay, so basically every x value, we're going to put in something here. And in this problem, we're going to put in a -5. Now, you might be tricked here or stuck, and a lot of students want to do that opposite sign. You could think of it as a -1, and that would be multiplication. So if that's the case, then you have to do that after parentheses and exponents because of PEMDAS. So that'll be -5 squared is +25, and the opposite of that is -25. +30 minus 9, and that'll become 5 minus 9, which is -4. Again, feel free to use a calculator. And what did we put in there? -5. Let's go ahead and try our next one here. So a negative sign, squared minus 6 times something minus 9, and that something is going to be -4, which I got over here. And let's simplify that Negative 4 times negative 4 is positive 16. Opposite of that is negative 16. Positive 24 minus 9. And that'll give us 8 minus 9, which is negative 1. So negative 4, negative 1. Okay, let's try the next one. So every parentheses now represents the x value. And the x value that I have for this problem is negative 3. Negative 3 squared is positive 9. Positive 9 times negative 1 gives you negative 9. Negative 9, oh, sorry, positive 18 minus 9. And all of that is going to equal 0 is my answer. The answer goes on the right side, and what you inputted there is your x value. So input, output. Let's try our next one here. And we get to put in here negative 2. So that'll become 4, negative 4, positive 12 minus 9. That'll be 8 minus 9, which is negative 1. And what did I put in there? Negative 2. And our last one, what should we put in there? Negative 1. So this will become positive 1, negative 1, positive 6 minus 9. So that'll be 5 minus 9, which is negative 4. And what do we put in there? Negative 1. And I want to point out something. Do you guys notice here in black, my answers are the same here? The blues, did you notice that? I hope you did. All right. And we're going to the negative side. I don't know how that works. And let's go this way a couple of directions. And let's do negative 5, negative 4. Left 5, down 4. Left 4, down 1. Negative 3, 0. Negative 2, 1. So left 2, down 1. And the red 1, left 1, down 4. Here is my, what color do you guys want? Orange? Pretty good, pretty good. I want to point out something. We haven't done this quite a bit, but you know, we said the axis of symmetry is negative 3. Take a look at this. X equals negative 3, that's the x-axis, so this is negative 3. And this dotted line is the axis of symmetry. It's a mirror. And how many times does this, well, remember, it crosses once, but that's a double root or double solution. So we're going to say 2 real solutions and x equals negative 3 and x equals negative 3. Or again, you could have said like something like 2 real solutions at x equals negative 3 with a multiplicity of 2. And question number 9. Let's go ahead and get standard form right below. It's easy as A, B, C. And if you get stuck, there is a 1 here. So A equals 1, B equals -6, and C equals 5. We're going to find our vertex with this formula, x equals -b all over 2a. B value is -6. A value is 1. That'll become -6 over 2. So I want you guys to notice how when I simplify, I actually leave that negative sign to the very end. So you'll get -3 and x equals +3. Super important. Where does that go? Where does this axis of symmetry go? That always goes into this middle box. Always. Super important. Why is this super important? Because it tells you what values to pick for x. You can literally pick any x value, but it is easiest to pick values that are consecutive or next to it. So I'm going to pick 5, 4, 3, 2, 1. And my function here is x squared minus 6x plus 5. Every x value, I'm going to put in a parentheses. And that will show, oops, that's going to show the substitution. So now we got 5 squared, which is 25, minus 30 plus 5. So -5 plus 5, that gives me an answer of 0. And what do we put in there? We put in 5. Let's go ahead and try 4. Same thing. That space there is for every x value, and x equals 4 here. Let's go ahead and simplify that. You get 16 minus 24 plus 4, so -8 plus 4 would give me -4. When x was 4, my answer, f of x, is -4. And let's go ahead and try the next one. I have here 3. So let's put in 3 here. If x is 3, let's go ahead and evaluate this. This will become 9 minus 18 plus 4. So 9 minus 18 is -9, plus 4 is -5. So when x is 3, my output is -5. Let's go and try this one here. Remember, we're doing the same problem here, basically 5 times. And what we're going to do here is put in what? 2. So 2 squared is 4. -6 times 2 is -12 plus 4, so that would be -8 plus 4, which is -4. When x is 2, my y value is -4. And the last one, every x value we're going to replace with 1. So I'm saying, instead of saying x squared, we have 1 squared, which is 1 minus 6 plus 4. So -5 plus 4 is -1. 1 comma -1. Alright, let's go ahead and put that in there. Let's double check some values we're going to pick. I think we're going this way and down. Alright, what do we got? 5 comma 0. So write 5. 1, 2, 3, 4, 5, and stay. That's the first one. Write 4, down 4. Write 3 down 5. Write 2 down 4. Notice how my greens are on the same Y horizontal line. And last one, write 1 down 1. Whoa, 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 whoa. Okay, so I want to highlight that I made a mistake somewhere because these two values are not the same. Let's double check. 5 squared. Oh, right there. Oh no. Did you guys see what I did? Oh no. Wow. The answer to the original problem is +5. Oh yeah, let's figure this out. Good thing, I think that's part of math, is making mistakes, going back and see if we can make them correct. Okay, so that is that one. -5 + 5 is 0. That one makes sense. -8. That would give me a -3. This one will give me -9, -4. And this one will give me -8 + 5 gives me -3. And this one, of course, is 5. So -5 + 5 is 0. Okay. So did you guys see how I knew that? I knew that these here had to be the same. And these also had to be the same. So let's go back and erase my little dots. All right. Write 5 up here, 5, 0. 4, -3. Write 4 down 3. Write 3 down -4. Write 2 down -3. And write 1, 0. Now, to double check that you basically just also find those 2 points, you can always just you can make y = 0, but for right now, you guys do not know other methods of cooking the potato or solving the quadratics. So we have 2 real solutions at, this is 5, so x = 5, and x = 1. And those are our solutions for question number 9. Let's go on to question number 10. We're going to graph this. Find our A, B, and C. Find the vertex. My B value is 2. My A value is 1. And you need to write that formula down every time because I know you're going to mess up. Don't do it. So I got 2 over 2, and then I take care of that negative sign at the end, so I get x = -1. So basically what we've done is what did we do? Make sure it's set equal to 0, find the axis symmetry, use the table of values, graph it, and then figure out how many solutions we have. All right. All right, so let's go ahead and, again, this is the most important one, the axis of symmetries. Where do you put that in there? It's always in the middle box, or the third one. Why do you need to do that? Because it helps us find other 2 points that are consecutive. So I have x squared plus 2x plus 3. And let's go ahead and just substitute in. Basically, every x value is just going to go down that column and in here. What does that look like? That'll be, so you can see that column. Then I'm going to put in a -3. And that'll give me 3 plus 3, which gives me 6. Okay, so let's do that for the next one. So same thing. We're doing 5 mini problems, but now we have -2. So -2 squared is 4 minus 4 plus 3. So 4 minus 3 is 0. 0 plus 3 is 3. So when I put in -2, I get 3. Let's try that with this one here. So I get -1, -1. I got 1 minus 2 plus 3. This will give me -1 plus 3, which is 2. Alright, let's go ahead and try this one here. We're going to put in, what? 0. That'll give me, I put in 0, and I get an answer of 3. And last one. What are we putting in here? Putting in a 1. So 1 plus 2 plus 3 gives me 6. 1 comma 6 is my solution. Let's go ahead and graph that. Look ahead. I have -3, -1, -2, going up to 6. 1, 2, 3, 4, 5, 6. Do your best to make them equidistant. So -3, 6, left 3, up 6. -2, 3, left 2, up 3. Left 1, up 2. 0, and then go up 3. And then right 1, up 6. And we have a graph that looks kind of like this. Ooh. Okay. Question. Does it go through the x-axis? It does not, so there are 0. Another word for 0 is no. Do you want any mayonnaise on your sandwich? And you say, I want 0 of it. That means there are no or none, no real solutions. It does not cross the x-axis. In this problem, you would have 2 imaginary solutions or complex solutions, which we'll get into soon. All right, number 11. What do we got? I got A is 1, B is -3, and C is -10. And put an axis of symmetry, -b over 2a. Always write that formula down. And let's just kind of substitute that in. My b value is -3. And my a value is 1. Oh no. Do you guys see what's happening? Dun. I got a fraction. Never fear, Mr. Ng is here. So this one will always go in the middle. And there's 3 halves. Okay, 3 halves, if you put in your calculator, $3 divided by 2 people is 1.5. So right above it is 2 and 3. And below it, let's just say 3 halves is between $2 and $1. So that would be the next point there. Okay, so we're working with and I'm just going to put there all these parentheses. Now, why do I do that? Why do I do that? Oh, I thought about something. You just copy and paste this. Duplicate, boom. Duplicate, boom. Duplicate, boom. Technology! Duplicate, boom. Well, that was cool. Okay, so this problem we're going to put in 3 for every x value. 3 squared is 9 minus 6 minus 10, so that'll be 3 minus 10, which is -7. All right, what do we got? We got a 2. 2 squared is 4 minus 6 minus 10, so -2 minus 10 is -12. Uh-oh, uh-oh, uh-oh. Okay. Let's put in 3 halves. Okay, that just basically means 3 halves times 3 halves. And all you have to do here is just multiply across. So you will get 9/4. Make that a fraction, multiply across, you get minus 9 halves. Let's put this over 1. And my lowest common denominator for 2 and 1 is 4. So, watch this. I'm just going to multiply this one by 4. This will give me -40 over 4. If I multiply this one by 2 over 2, this will give me negative 18 over 4. Can I move this? Let's do it. Magic. Oh yeah, I love this thing. -18 over 4. Okay, so we all have a common denominator now, and then you can just 9 minus 18 is -9, -49 over 4. Woof. -49 over 4. And what do we put in there? 3 halves. Last problem we put in a 2, and that one was a 3. Okay, what do we got here? We got a 1. 1 squared is 1 minus 3 minus 10. -2 minus 10 is -12. And what do we put in there? 1 comma -12. Alright, what's the last one? Oh yeah, my favorite 0. 0, 0. 0 minus 0 minus 10 gives you -10. So we're going to have 0 comma -10. Let's graphy maffy here. All right, my numbers get kind of big, so what I'm going to do is I'm going to count by, this will be 1s, and then this one will be 2, so that'll be -2, -4, -6, -8, -10, -12. Okay, let's try it. We got 3, -7, so that would be right 3 down 7, -2, -4, -6, and not -8, so right in between it. And 2, negative 12. So write 2 down, negative 12. Okay. You can put that into your calculator, which I will do. Negative 49 divided by 4. Okay, negative $12 or $12.25. $12.25. Let's write that. So it's just like right past 12. So 1.5. Let's do that one. 1.5. So 1, 2. So right there. 1.5 and negative 12.5. It's just a little bit past it. Like that. There in red. Okay, so we have right 1 down negative 12. And then my last one, 0, negative 10. Oh. And I did it again. Let's see. 9 minus, should I see that? Should I see that? No, it's still wrong. What? Negative 10. Learning from mistakes. That's negative 9, which is 0, which goes as negative 10. 3, negative 10. 3, negative 10. So I'm going to erase this one. That would be negative 8, negative 10 right here. Okay, here's the bad thing. And it'll lead to a segue for our next section. Pencil working here. Okay, so if I kind of just connect the dots. Okay, so I don't have points out here, right? I can just say for now that I have 2 real solutions. 2 real solutions. At, okay, so I don't know what this red one is. And this yellow one. Okay, but we're going to learn this, so I might as well just show it to you. I'm going to put that into the calculator. X squared minus 3x minus 10. I'll go way slower when we do it. Y equals x squared minus 3x minus 10. That's what I said, right? Let's double check. Yep, okay. Oh, okay. Press graph. And let's pinch in there. And let's just zoom in like crazy. Oh, look at that value. Ooh. Okay. So play around with it until you get something like this, okay? And the cool thing about a graph calculator is you could just literally put your finger on it. And I want the y value to equal 0, so you can do something like that. Just kind of drag your finger. Boop! Oh yes, it says 0. Perfect! 5, 0. And then doot, negative 2, 0. So we know what it is. Okay, so that red one, yellow one's 5, red was negative 2. So you can see that was my estimate, guesstimate, and we actually found what it was. And there's the answer. All right, last one here, number 12. Let's write standard form. And there's a 1 right there, so A equals negative 1, B equals negative 8, and C equals negative 16. Whoops, too many negatives. And let's see, we need to find the vertex. And got a b-value -8. And we have a value -1. So we're just replacing here. That's what means to evaluate. And you have a 2 here with parentheses. So leave the negative sign to the end. -8 divided by -2 gives me a +4. And that just becomes x equals -4. Okay, super important. That value will go into the middle of our table. So let's put in -4. Let me go ahead and get a value here. -x² minus 8x minus 16. And let's go, well, technically down, but we're going up. I don't know if that makes sense. Because if it was like a number line, and you did a vertical number line, negative numbers go down or to the left. I know you guys think I'm crazy. Okay, negative, and instead of writing x, I'm just going to do the parentheses. And basically we're going to do 5 mini problems. 5 mini problems. So I just, boom, copy and paste. Oh, no. Oh no. Oh no. Oh no. We gotta start again. No, and you missed a 6 there. Great. Let's clean that up. Alright, here we go. -6. Numbers get too big, feel free to use a calculator. This will become -6 squared is positive 36, -36, positive 48, minus 16. Oh yeah. So that's going to give me a -12, -28. -6, comma, -28. Okay, let's try -5. -5, -5. So that comes 25, -25, positive 40, gives me positive 15. That would give me -1. So -5, comma, -1. All right, here we go. -4, 16, -16, positive 32, positive 16, -16, you get 0, -4, comma, 0. And let's go ahead and put in a -3 here. That becomes 9, -9, positive 24, positive 15, minus 16 gives me a -1. We put in -3, got -1, and that matches, right? See the reds? And green, what do you think it should be? It should be a -28. Let's see. So we got a -2. That become positive 4, -4, positive 16, -16. I said because, okay, that's bad. I think that's 0, and this one comes -4. What happened? 36, -36, 48, 12. 12 minus 16 is -4. Do you guys see that? I was kind of like, okay, one of them's going to be wrong. And good thing for erasers. We make mistakes, that's okay. Okay, that's -4. And this one will be -2, comma, -4. All right, let's graph this. Can you predict? We'll cross the x-axis. I don't know. Let's see. Ow, hurt my shoulder. -2, 3, 4, 5, 6, and then we're going to go down to -4. 1, 2, 3, 4. All right, what do we got? -6, -4. Left 6, down 4. Left 5, down 1. -4, 0. Left 3, down 1. And left 2, down 4. And let's see it. See if we can move it a little bit. Trying to like bing, 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 bing. Do you guys see what order pairs are? They are actually solutions. And there's a billion little dots there, but we've just pointed out ones that are perfectly on the graph with nice coordinates that are whole numbers or integers. So how many solutions do we have? Magic numbers, because it's quadratic, we actually have 2 real solutions. It's kind of weird. I want you to start doing this. X equals -4 and x equals -4. It's a double one. You write -4 twice. All right. Hopefully that was fun. All right, let's go over 1.22. It says 2 real solutions, but basically they're kind of like quadratic word problems. So steps to solving quadratic word problems by graphing. A couple of things you can do that are super helpful is I'm going to call this, my pen's not working, step 0. Define the variables. And basically what that means is just like, what is x equal to? And then when you're actually doing the work, step 1, you can solve the equation for 0. Step 2, you can find the axis of symmetry, AOS, line of symmetry, axis of symmetry. Step 3, a table of values, And step 4, determine the zeros. And remember, zeros are x-intercepts. Those are synonymous, same names. Okay? All right, let's try this question here. This example says, use the quadratic equation to find 2 real numbers with the sum of 24 and a product of 143. Okay, sum is just, well, before we do that, I forgot we should just go through my steps, duh. Step 0, define the variables. X is the, represents one number. Right? It says 2 real numbers, and then I have x here. Okay, so how do I get this second number? The sum of these 2 numbers, so x plus the second number, which I'm going to call x, sum is plus. So you add them together, and it equals 24. Now, we're not quite sure that the numbers are the same, so you can call the second number like, because if you said x plus x, we're inferring that they're both the same. So let me just call that y. So x represents one number and y represents the other number. Okay? So what you can do is you can say something like, if you subtract x, you get y equals 24 minus x. This here represents an expression. The second number is equal to 24 minus the other number. One of those numbers is equal to 24 minus the other number. Okay? And we're still under step number 0, defining the variables, which we did. But I also want to show you here in blue, which step 0, is that the same product of those two numbers. So if I said something like x times y, those two numbers, if I multiply them together, product means multiplied, equals 143. Well, now we're saying that y represents 24, so I'm doing a substitution here. So x times 24 minus x equals 143. Okay? So that is essentially my equation. So let's mark this. So step 0. Okay. Let's do this in green now. Step 1 is solve this equation for 0. Basically, we're going to set it equal to 0. And what I'm going to have to do here is, let's go ahead and distribute. So that would become x times 24 is 24x. In order to put the number, then the variable or letter. X times x is called negative x squared. And I'm going to subtract this 143. Let's keep it on the side. And the reason why I'm switching this, why you're like, Mr. Why'd you do that? I'm going to move everything to the left side. And I'll tell you why I'm doing that is so that I can get x squared to be positive. Positive. You'll see a reason why. So let's go ahead and do the opposite. So subtract 24x and add x squared. What I do to one side, I have to do to both sides. What I give to one kid, I have to give to the other kid, right? Shouldn't use that one. So this is 0. 0, 0. So you're left with x squared minus 24x plus 143. Okay, so there I have step 1. Let's move it over here. Step 1, we solve the equation for 0. Okay? Okay, let's review what we've done so far. We've defined our variables. We solve the equation for 0, and now we're going to do the axis of symmetry. The axis of symmetry. The formula is x equals negative b over 2a. And from over here, I have, remember the number in front of x squared is a, so that would be 1. There is b, the number in front of x, and the number all over here is just c. Okay? So I can just substitute those numbers. A is 1. Let's write that. B is negative 24. Let's fill all this out. So I have negative 24 and 2 times 1. So this will give us, let's see what we got here. Negative 24 over 2. And here in parentheses, that becomes negative 12. And then you have the opposite of negative 12, or you can say negative 1 times negative 12 is positive 12. So x equals 12 is my axis of symmetry. All right, let's get a table of values here. One, 2, 3, 4, 5. And we're saying this is x, my function, over here. So that would be f of x equals x squared minus 24x plus 143. And we're saying this is our solution here. Remember, where does that go? Most important, that goes right in the middle. Always. So that'll be 12. And then you can just pick some numbers that go above it. 13, 14, and 11, and 10. All right, let's go ahead and... Okay, let's go ahead and put 14 in here. 14 squared minus 24 times 14 plus 143. So I'm going to get my calculator. So 14 squared is 196. 24 negative times 14 gives me negative 336 plus 143. Just put all those numbers in. And I get the wonderful answer of 3. When x was 14, f of x becomes 3, or my y value becomes 3. Let's go ahead and try 13. 13 times 13 is 169. Negative 24 times 13 will give me negative 312 plus 143, so plus 143 plus 169, and I get 0. Answer is 0. Okay, let's do this one over here. We got 12. 12 squared is 144. 24 times 12 gives me negative 288 plus 143. Remember, when you're putting into your calculator, sometimes they have a negative button, different subtraction, and some calculators can actually do both. So if you get some kind of error, sometimes that's what it is. And I get negative 1. When x was 12, x is negative 1. Okay, remember the color-coded system here. What did you think the answer is going to be? Can you predict it? I think because the blue above, it should be 0. Let's see if that is our answer. Let's put in 11. 11 squared is 121. 24 times 11 is negative 264. I'm going to add that to 121 and add 143. And the answer is 0. Okay. Do you see the benefit of picking the axis of symmetry here? Okay. Okay, this one's going to be in green. So what do you think the answer is going to be? I think it's going to be 3. 10, comma, 3. Let's see. 10 squared is 100. 24 times 10 is negative 240 plus 143. So 10 squared, 100 minus 240 is negative 140 plus 143 gives me positive 3. There is our table of values. That was number 3 here. Okay, let's go to step 4, which is determining the zeros. So let's graph this. Basically, we're graphing it. Let's graph it. Okay, let's move ahead. Let's think ahead. All these values are on the right side. So at 10, 11, 12, so I'm going to draw it. Looks like that. And probably not going to be drawn the scale, so you could do something like this. Let's say this is 5, this is 10, and this is 15. So we can say 11, 12, 13, 14. And then we have 1, 2, 3. Okay, let's see what we got here. So 14, 3, so write 14 up 3. That's this one. 13, write 13 on the x-axis, and then stay, so. And then write 12 down 1, so write 12 down 1, something like this. Write 11, stay, and write 10 up 3. Pretty good, pretty good. And what are our two numbers? Our two numbers are x equals, this number is 11, and that number is x equals 13. Let's double check that. Let's see if that works. Or the second number, again, you could have said, kind of confusing, but we said it was y. So let's see. X plus y equals 24. Was that what we were saying? So that would be 11 plus 13 equals 24, and that is true. 24 equals 24. See, I'm checking my answer here. We said if you multiplied the two numbers, they were equal to 143. So 11 times 13 will equal 143. Does that make sense? So we basically use quadratic equations to solve the word problem. So those are my two real numbers. All right, directions for questions 13 and 14, skip one problem. Let's go ahead and do this one. Use a quadratic equation to find your two numbers. Kind of like the last problem, we chose it to be x and y with a sum of 2. So x plus y equals 2, and their product is negative 24. If I solve for this one in terms of x, I have y equals 2 minus x. And then if I put that in over here, this is going to be my equation. Does that make sense? So we define the variables. Let's go ahead and solve this for x. So I'm going to distribute here. And then I wanted the a value to be positive. So to do that, I'm going to move everything to the right side. See, there's opposites. Why do I do that? So that this is 0, this is 0. So this side is 0. Then I'll just put these in descending order. X squared minus 2x minus 24. Okay, so let's look at our steps above. Step 0, define the variables, solve the equation for 0, and now let's get the axis of symmetry. To get my axis of symmetry, so this was kind of like step 0. Step 1 here, we got it set equal to 0 right here. And now step 2, we're going to get the axis of symmetry. Okay, so I'm going to name my A, B's, and C's. So A is 1, B is negative 2, and C is negative 24. Which you don't really need C here, but our formula for axis of symmetry is x equals negative b over 2a. Always write down the formula. What is our b value? The b value is negative 2. And the a value is 1. Let's simplify that. Negative 2 over 2, that becomes negative 1, so that becomes positive 1. Let's make our table here. Where does that go? Right in the middle, always, 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 always. Okay, so I got 1, let's count up and down. And what is our function here? We have x squared minus 2x minus 24. So I got basically parentheses squared minus 2 times the parentheses minus 20. Da, 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 da. Okay, let's put in these values now. Let's put in 3. That'll give me 3 times 3 is 9, minus 6 minus 24. So 9 minus 6 is 3. 3 minus 24 is negative 18. Okay, let's do 2. 2 squared is 4. Negative 2 minus 2 is negative 4. And I get 0. 0 minus 24 is negative 24. Uh-oh. Not good numbers here. And I'm saying that because why am I saying that? Because I just want those numbers to match. That's all. 9 minus 6 and 3. No. Okay. Let's try 1. Let's see what happens at 1. I think I made a mistake. I can tell. No, sum of 2. Okay. What do we got? 1 minus 2 minus 24. That'll give us negative 3. This will give us negative 27. So here is the bad thing. It's getting us numbers. If you think about this, I'm looking for a y value that equals 0, so I get an x-intercept. And I'm not getting that. So this will be negative 24. This one is 1. Because you can see what's happening is I have it looks like the red coordinates, 1, negative 27, it looks like it's more of a minimum, like the lowest number. That makes sense. But we can put in our graphing calculator and see. All right, let's put this one, negative 1. Negative 1 squared is 1. Negative 2 times negative 1 is positive 2 minus 24. 3 minus 24 is negative 18. So I have negative 1, comma, negative 18. And what happens is if we graph this, let's see. 1, 2, 3. 1, 2, 3. Let's count by 8s. Negative 8, negative 16, negative 24. So I have 3, negative 18. So write 3 down, negative 18. Something like that. 2, negative, write 2, negative 24. Write 1 down, 27. And if you could just match them up, 0, negative 24. And left 1 down, negative 18. So just match up with the black one. Okay, so here's my graph. Okay, so here's the hard part. We know that our answers are, wait, pencil turned off. What do you like? Orange? These values we don't have. So what you could do is you can keep marching out by creating your table of values and keep going towards a bigger number and a smaller number. You can do that, okay? The point is that you can organize your answers or your data inside a table of values. Now, let's go ahead and put this into the graphing calculator. X squared minus 2x minus 24. Okay, clear. Go top left and you're going to click y equals. Clear this out. We're going to type in x squared. The squared button is to the left of there near the 7. Minus 2x minus 24. And we'll just press graph. And you can clearly see what our two answers are. It's called 0, 6 comma 0, and negative 4. So those two numbers that we needed, negative 4, and this would have been a 6. Okay, let's test those numbers. Negative 4 plus 6 would give us positive 2. So that matches. And negative 4 times 6 would give me negative 24. So the two numbers that we have there are negative 4 and 6. Okay, let's go ahead and try number 14. Use a quadratic equation to find two real numbers with the sum of negative 15. So we're saying our two numbers are like x and y. So x times y equals negative 15. And their product, sorry, that's sum. And their product is negative 54. Okay, let's solve for this one in terms of x. Okay, what I'm going to do is I'm going to substitute this one in now for y. So I have x times negative 15 minus x. This was step 0 to find. Step 1, we're going to now solve set equal to 0. Set equal to 0, which basically means we needed to get it to be 0. So if we multiply here, negative 15x minus x squared equals negative 54. And the goal is to set it equal to 0, and I don't want my a value to be negative, so I'm going to move everything to the, we're going to move all that to the right side, okay? So to do that, we do the inverses or opposites, so it's, just trying to color, sorry. Add 15x. Notice how I didn't line them up because they're not like terms, and x squared. 0, 0, x squared plus 15x minus 54. Okay, step 2 is the axis of symmetry, so I need my a, b's, and c's. So we've been doing this all the day long. The number in front of x squared is a, b is 15, and c is negative 54. If you need help with that, you can always write standard form right above it. Go, standard form. Okay, axis of symmetry. Our formula is x equals negative b over 2a. And our b value is 15. And our a value is 1. Let's write that in. X equals 15 over 2 times 1. Oh yes, and look what they did to us. X equals negative 15 over 2, which is your favorite of fraction. Now, you could keep it a fraction, but decimals also help us with understanding of where it is. Negative 7.5 is between negative 7 and 8. So, most important, this one goes right there. So negative 7.5, and like I told you, it's between negative 7 and negative 8. Okay, let's write down our equation here. Let's highlight that. I keep losing it. Here it is, in blue. Let's write that there. X squared plus 15x minus 54. And every x value, I'm going to put in the parentheses to show my substitution. So negative 9. Let's get a calculator. Negative 9 squared is 81. 15 times 9 gives you negative 135 minus 54. And plus 81 minus 54. Let's double check. Okay, so I got negative 108. Okay, it looks like we have the same thing. Let's see what happens. Let's put in negative 8. So it becomes positive 64. 15 times 8 gives me negative 120 minus 54. Negative 110. Not good. Alright, let's try this next one. Something squared plus 15 times something minus 54. Okay, let's see. Let's put in negative 7.5. 7.5 times 7.5 gives you 56.25. 15 times 7.5 gives me 112. And that should be minus minus 54. Okay, negative 110.25. That was at negative 7.5. So because the graph is opening up, because a is equal to 1, my vertex would be in the lowest point at negative 110.25 on the y values. All right. And let's try negative 7. Let's put in our values. Negative 7. So I got 49, 7 times 15, negative 105 minus 54. Negative 110. So negative 7 comma negative 110. Oops, that should have been green, huh? Green. Cool. Okay. Let's do blue now. And we got negative 6. So 36 plus negative 90 minus 54. 36 minus 90 minus 54. Negative 108. Did you see any values that are y values equal to 0? I did not. This is not going to be fun. It's okay. Still have fun, okay? How would I do this? Okay, the y values are by, let's count by tens. Or, blah, 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 blah. That's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if that one's negative 10, that'll be negative 111. And I need the negative sign, so negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's see what we got. Let's do our best. So left 9, down 108. Left 8 down negative 110, so a little bit lower. Super close, negative 7.5, negative 110.25, so just a little bit further. Left 7 down negative 110, which is the same thing as the green. And the blue. Negative 6, negative 108. Okay, here is our problem. I think you already see it. I was supposed to find something here in the red dots. Was one of our coordinates have like x comma y to be something comma 0? No. So we'll turn to our graphing calculator. X squared plus 15x negative 54. Done. Y equals, you can just plus 15x minus 54. Let's press graph. And you can move over. So I have my two answers here. That would be 3 and negative 18. Does that make sense? If you add those two values together, you will get negative 15. And if you multiply those together, you'll get negative 54. So those are our two solutions for those two problems. All right, let's go over 1.23, estimating roots. What's our steps to solving quadratics by graphing and estimating? The first thing we need to do is solve, kind of like we did, but no step 0. So step number 1, set equal to 0. To solve quadratics, you always have to set them equal to 0. Number 2, we're going to find the axis of symmetry. Write that in your formula sheet if you haven't already. That is x equals negative b over 2a. Number 3, make a table. And I just want to reiterate that in the center of your table, center around AOS. What that means is this value, whatever it is right in the middle. It's in the middle of your table. And number 4, we're going to graph it. And then 5, we're going to get our solutions. Get solutions. And we might have to do something in this case called to estimate. It's almost there, but we'll look at whole numbers. Okay? Let's do this example together. Solve negative x squared plus 3x plus 7 by graphing. If the exact roots cannot be found, state the consecutive integers between which the roots are located. Okay, let's take a look at this one. So, we have the first one. Yes. Let's get our A, B's, and C's. A, B, C. Easy as 1, 2, 3. Okay, no number. What is it? Negative 1. B is 3, and C is 7. Okay, axis of symmetry. Let's use that formula there. What is our A value? It is negative 1. And what is our B value? It is 3. X equals a negative 2 times negative 1. So this will become x equals 3 divided by negative 2 is opposite of that would become positive 3/2. Now, to give you some kind of number sense, if you put that in your calculator, $3 divided between you and I is 1.5. Box that is our answer here. This is our axis of symmetry. So let us remind each other what we've done so far. Number 1, it's already set equal to 0. Number 2, we found the axis of symmetry using the formula x equals negative b over 2a, and now we're going to create a table of values. Let's go ahead and do that. And our function is negative x squared plus 3x plus 7. And our answers, our solutions, are order pairs. So, where does this one go? Super important. Like we just said, it centers around the axis of symmetry. So this is my axis of symmetry. Always, always, always put it in the middle. Okay, what are we putting there? You can put in the fraction or you can put in the decimal. It is your choice. It's good to use fractions and know how to do them. So let's just put in the decimal. to help us with number sense. So $1.50 is between $2 and $1, and you can go from there and go down. Okay, let's go ahead and evaluate this. Something squared plus 3 times something plus 7. And if I have here 3, this will give us 9 plus 9 plus 7. So this would give us 18 plus 7 is 20. But 3 squared times 9, 18 plus 7. Oh, did you guys see what I forgot? Super important. Negative. So 3 squared is 9. Opposite of 9 is negative 9. Negative 9 plus 9 is 0, and that will give us 7. So our answer is 3, 7. Okay, let's keep going. Okay, let's do now. What are we doing? Let's do 2. So 2 squared is 4. Opposite of 4 is negative 4. Plus 6 plus 7. So negative 4 plus 6 is 2. 2 plus 7 is 9. So I'm going to get 2, 9. Okay, so let's do 1.5. Opposite of something squared plus 3 times something plus 7. Let's put in here 1.5. 1.5 squared is 2.25, and opposite of that is negative 2.25. And 3 gives me 4.5 plus 7. So if I add those together, I'll get 2.25. Let's just double check. Minus 4.5, and then plus 7 gives me 9.25. So 1.5 and comma 9.25. Okay, let us go. Okay, so let's keep going. So let's put in here 1. This will become 1 squared, 1, negative 1, plus 3, plus 7. 2 plus 7 is 9. 1, 9 is my answer. And let's do 0. Put in 0. 0 squared is 0. Opposite of 0 is 0. 0 plus 3 plus... That's a 0. 0 plus 0 plus 7 gives me 0, 7. Okay, what did we just do here? This is step number 3, table of values. Let's go ahead and graph this thing. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I cannot draw straight lines. Boom, thank you. Okay, that is 9, and that's a 1. Let's go ahead and graph that. Write 3 up 7. So right here. Write 2 up 9. Now remember, the e-value is negative, so it's going to open down. My graph's going to be down. That's how you know if it opens up or down. Write 1, so between $1 and $2, 1.5 and 9.25, so a little bit higher. There's our vertex. There's our maximum. I already knew that. That was this one. Let's do write 1 up 9. Wrong color. Green. Boom. Yeah. Okay, and blue, 0, 7. Stay and then go up 7. That's a blue. And this is our graph. Whoa, did you see that? I think because I went over it a couple of times, but this is my graph. Okay. Question here. What will these numbers be? Now you could keep going. I have 0, 7. And I'm just going to tell you some numbers. -1, so this will become -1, comma 3. And then if you did -2, you'll get -2, comma -3. And if you did 4, you'll get 4, comma 3. And if you did 5, you will get 5, -3. Okay? Now, let me show you how to do that with a graphing calculator to get those table of values. You go to your calculator, press Y equals in the top left. Okay, negative is next to the decimal, not a subtraction sign. My trick is xx, which is right next to alpha, plus 3 times x plus 7. Okay, now I'm going to do something called table set. So you're going to press second table. And I want you to be on auto. And you can start at -5, sure, and change in the table you want it to go by ones. So you can just scroll down and press 1, okay? So go to table now, which is above the up key. Whoa, 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 what is this? What is this? It has all the answers. It's telling me all the answers. Okay, how is this important for us? Okay, so we don't see any y values that are 0, but I do see ones that are between 3 and -3. So let's take a look at this. Okay, so what they're trying to say is, here is my answer. Let's see. Okay, between these purples is, let's just say you had something like 4.1, comma 0. It's between a positive and negative value on the y's. Let's say that again. My answer has to be between, let's write that, x is between 4 and 5. Okay, and the other one, x-intercept is between x equals -1 and x equals -2. And I can even tell you what that exact answer is using my graphing calculator. So press graph. Play around with it if you want. Okay, so watch that. Do you see it? I saw decimals. Did you guys see decimals? Ah, yeah, decimals. Do you see that? This, as I go here, is between -1 and -2 on the x-axis. It's exactly -1.54. So I knew that it was between -1 and -2. Look over here. This number is between 4 and 5. Okay, so when y equals 0, that's an x-intercept. That is our big idea here. And so what we're doing is we're just estimating them. They'll be between those numbers. Okay? All right, let's go ahead and try. For questions 15 to 17, skip one problem, solve each equation by graphing. If no exact roots can be found, state the consecutive integers between the roots are located. Okay. I'm going to tell you, go ahead and use your graphing calculator because it's going to go a lot faster. It's just taking too long if you're creating a table of values and then the quadratic equation the book picked, then they kind of like pick the wrong one. You know what I'm saying? All right, so we got a lot of these. Let's go. Number 15. Done. Y equals x squared, just go back here and change this. Look, minus, that's around the operational keys, which are dark blue, 4x plus 2. Okay? And you can get a table of values. Let's see if I can do this. Table. And they're called inflection points. Inflection points. It's when the y-axis is changing between a positive and negative value. There's a change between a positive and negative value. So I can see it right there. It's between 0 and 1. And right there. Between -4 and -5. Let's double check. Oh, that was my mistake. That shouldn't be there. Let's try that again. Okay, where do I see the numbers change on the y values, the y side, the right side, between a positive and negative? That is between where x is 0 and 1. And if I move this again, and I'm trying between a negative and positive, that's between 3 and 4. Here's a visual. Press graph. Okay. I love how it changes the decimals. Do you see how, if you click right on it, it'll give you a 0. But that is between, on the x-axis, 0.5857 is between 0 and 1. And the other one is between 3 and 4. So let's just draw a graph so we have a visual. And we said it was between 0, 1, 2, 3, 4. And between 0 and 1 and 3 and 4. And this is what my graph kind of looks like, right? Something like this. So then we're saying the yellow one is between, shouldn't use yellow, whoops, between 0 and 1. That's what that one is. And this one over here is between what? Between 3 and 4. All right, let's try number 16. And I don't know, I could try. All right, let's go over number 16. I said it was okay, just go into your graphing calculator. Y equals x squared plus 6x plus 6. Go ahead and press, if you want to see a table, press table. And we're looking for numbers that change between negative and positive, where the numbers change between negative and positive. I'm going to take a picture of that. And you're already going to see the answer here. When we graph it, where does it cross between the x values? It's between -1 and -2, and between -4 and -5. Okay, so let's just quickly sketch that graph. We said between -1 and 2. -1, -2, -3, -4, -5. So we said one of those is between -2 and -1. And the other one's between -4 and -5. And the graph is opening up. Okay, that's enough. So we can say between -1 and -2. This one is between -4 and -5. Okay, let's see what this looks like on table of values. That's what I want to show you guys. And I wrote down x, y's. -5, -4, -3, -2, -1, and let's just put 0. So I have 1, 1, -2, -3, -2, and 1. Okay, so hopefully you can see that between 1 and -2 is right here. Do you see how these values here are switching from negative to positive? Which means that what? 0 is between them. Same thing over here. Between -4 and -5. You guys, you can see between right there. Negative or 0 is between them. Does that make sense? All right, let's try number 17. Let's put it in. X squared plus 4x plus 2. And let's get a table. I'm going to take a picture of this table. Okay, and then let's put a graph. And it looks like this one is between -3 and -4. There's the exact one. You see how the order pair is -3.4 comma 0. But in our table, we don't have decimals. Does that make sense? And then over here, we can do that's between 0 and -1. So let's do the graph. Between 0 and negative, let's do this first. So between 0 and -1, and the other one we said was between -3 and -4. And our graph looks something like this. And our table of values. -4, 2, -3, -1, -2, -2, -1, -1, 0, 2. And so this in blue right here is, that's supposed to be blue, right here. Do you see how the y value is between this positive and -1? Same thing over here, between 0 and -1. It's between an x value of 0 and -1. Okay, let's go ahead and try. It says question number 18 to 23, skip 3 problems, solve by graphing. Go ahead and just graph it using your graphing calculator, and then we're just getting our solutions. So let's put number 18 in here. Done. Y equals, clear if you wanted to, negative x squared minus 4x. Okay? And then go ahead and type in, get a table. And you're looking for a table, values. How do you know how to go up and down here? You're looking for values where your y value is 0. Or the change between positive and negatives. You go to graph. You can see it. Ooh, look at this one. What do you guys notice? It's actually going exactly through it. You see it? -4, comma 0. 0, 0. So this one was nice because it was going through 0, 0 and -4. And the graph looked like this. And then the table of values was something like this. -5, -5, -4, 0, -3, 3, -2, 4, -1, 3, 0, 0, and 1, -5. So in blue there, you can see how there was a negative, there was a positive sandwiched in between, but there is 0. And then I can say the number is between what? -3 and -5, but we already know it's -4. So the answer is x equals 0 and x equals -4. But I'm trying to point out, if you look at between this one, this is between -1 and 1. There's a positive, there's a negative, but this is the number that's in between it. It's going to be 0 is going to be between positive and negative number. That's the point here. All right, let's do this a couple more times. Let's go to number 19. Let's get a graph. Done. Y equals, clear, negative xx plus 36. Let's get a table. And graph. Okay, you can zoom in and you can see that it actually goes through 6 and -6. And remember the C value in this case, this one actually is called up. Goes directly through that. And let's create our table of values here. If you did -7, 49 minus, that would be -13. And what I'm trying to show you guys here is where it is on the table and well, you would have to go all the way up to the positive 6. I'll just show you guys the blue one. The blue one, the answer is between -7 and -5 right here. There's a 0, and 0 is between a negative and positive number. So our answers are x equals -6 and x equals a positive 6. Okay, let's go ahead and try the graph in the next one. Number 20. X squared minus 6x plus 4. Let's get a table, and again, I need two numbers that will let's see, 0 and 1. All right, this one's nice. Take a picture of this one. Okay, so number 20, we have this one was between this one was between 0 and 1. And that's referring to the x values. And this one is between 5 and 6. 1, 2, 3, 4, 5, 6. It's right here between 5 and 6. Okay, so table of values. Zero, 4, 1, -1, 2, -4, 3, -5, 4, -4, 5, -1, and 6, 4. Okay, so this blue one is between 0 and 1 on the x values, and look at the y values. Right here is where 0 should be. Oops, I didn't even draw a parabola on this one. And the green one is between 5 and 6. You see how there is between a, here on the y value, the 0 should be between -1 and 4. Alright, let's look at number 21. Let's go ahead and graph that. Y equals, clear. Again, you can do x squared, which is over by the 7, plus 5x plus 3. You get a table. Take a picture. Maybe I should move over to an app called OneNote. Someone was noting that to me. And graph it. So you can kind of zoom in here. Between 0 and -1 and -4 and -5. Between -4 and -5, 0 and -1, and that's seen in a table of values. And the blue is between -4 and -5. You'll see that in the y values, there's a change from a positive to a negative. There's 0, because something comma 0 is your x-intercept. Same thing between 0 and -1. On the y values, there's a change between the positive and negative, and 0 is going to be right there. And I think that's something what our graph looks like. Let's go ahead and try question number 22. 22, I'm going to put in that, x squared minus 7. Table. I'm looking for where it changes from positive to negative. And you just take a picture of that. Go to graph. I see between 2 and 3, and -3 and -2. 1, 2, 3. 1, 2, 3. And between -2 and -3. And between 2 and 3. Box your answers, 2 and 3. That's what our x value is. So we get table of values. -3 to -2, -3, -1, -6, 0, -7, 1, -6, 2, -3, and 3, 2. So -2 and -3, the reason why is you're looking for the 0, which is between a positive and negative number, so your answer is the x values. And between 2 and 3, again, right here, right between these two numbers is a change between the positive and negative, so there's 0. And the last one for this set, let's put number 23 in. Negative x squared minus 4x minus 6. Let's graph it. Uh-oh. Okay, question. If you zoom in or out, will it ever cross the x-axis? The answer is never. So if your graph looks like this, it's never going to cross the x-axis. So we would say no real solution. And that is your answer for number 23. All right, let's go over 1.24, solving quadratic graphs by using a table. Steps to solving quadratics using a table. And I'm using an iPad, so I have this thing called Graph and Calc 83. And basically what it is, it's a Texas Instrument TI-83 graphing calculator emulator. A long time ago, there was other ones called Wabbit, Emu, or something like that. And basically what you want is a free graphing calculator on your phone, or if you have a physical one, so it's good too. The next thing we're going to do is we're going to press the enter the function, so enter function, and you're going to do that by clicking on the y equals button. Okay, once you do that, you're going to view the table. So view the table. And you're going to view the table by doing a couple of things first. Is you're going to click on second. And you're looking for, on my Texas Instrument, it might be a little bit different, but you're looking for the word window. And what this is going to do is we're going to do something called table setup. We're going to figure out how to set up the table. And when you view the table, basically what we're looking for are sign changes in the x's and y's, but then we're looking for y value 0. So change that means delta, which means change. So change in the table, it'll say TBL. You want to change it to 0.1. So that's one thing you need to do in there. And then the second thing you want to do is, if it asks you independent, you can do ask and dependent. Also ask. And basically what that is, this is the x coordinate, and this is your y coordinate, f of x. And then you can also use a graph to kind of help you. Okay, so let's go ahead and try this first one here. It says use a table to graph negative x squared plus 5x minus 1 equals 0. So here is my graphing calc 83. I'm going to get to the home screen. So I'm going to have to press y equals in the top left there. And I'm going to go ahead and insert my function. Negative, so the left of the enter key, x squared plus 5x minus 1. And now we're going to go to table set. So for mine, that would be second table. When I said second window, that was actually on a real graphing calculator. And you can start at any number. 0 is fine, but we said change this to 0.1. And you want it to be on auto. And let's now go to the table by clicking on the table button. Okay, so here you're going to notice a couple of things. Let's go back and change that to, oh, I understand. I wanted this one to be 1. Delete. Okay. Okay, so from here, you can see that if you change it back to, sorry, and then this one you want 1, you're looking for changes in on the y side from a negative to a positive. So I see one there between 0 and 1. And I see another one between 4 and 5. And then what we're going to do is we're going to try to even get better than that. So let's change it now to 0.1. So we already said that it was between 0 and 1. So if I go up here, between 0 and 1, that one where it says kind of like negative 2.776 e to the negative 17, that is just scientific notation. It says 0. And what I'm trying to get is, on the y side, a number super close to 0. And now we can try something. Say go to table 7, it's 2.01. Go back to your table. Remember, we knew the answer was between 0 and 1. Just scroll and find it. Okay, right there. See, it's between negative. It's around 0.2. And you see it's negative and then no longer negative, so let's try again. Let's start at 2 and we'll go 0.001. Again, we're looking for a number. Started at the wrong number. Let's try it again. Second table set. I want it to start at 0.2. Okay, now we're looking for a number very close to 0. Okay, there is between negative 0.208, the y1 value is negative 0.003. And at 0.209 on the x, the y is at 0.001 positive. So I can say that one of the x's is at 2.09. Okay, and there was another one. I think we said it was between 4 and 5. So let's just change that. Start at 4. Keep scrolling. I can scroll. I'm looking closer to 0. So remember, it's going to be, if you know, 4 and 5. We're at 6's, 5's, 4's, 0.3's, 0.2's. It doesn't go anymore. I wonder why. Let's see. Second table set. 4.6. See what happens. Oh, you see, start had negatives. So I think I'm at 4.791. 4.791. Right, so we had a graph. And this is here past 0. And this one is at 4. More than 4. So it's like 1, 2, 3, 4. Sorry, kind of bad, but What I'm trying to show you is that they're between the tick marks. That one didn't help. Yeah. Okay, so those are my two values just using the graphing calculator. Okay, let's go on to questions 24 to 26. It says skip one problem, use the tables to determine location of the zeros for each quadratic function. State the consecutive integers between which the roots are located. So let's just make sure, remember the roots are another word for x-intercepts. And that's basically when y is equal to 0. So the question is, where on question number 24 do you see a change between negative and positive? Well, they changed the table, so if it's a little bit confusing for you, you have the x's and then you have the y's, right? And we're looking at the y's, and then right here, I see a change, right? Because 0 is between negative 1 and 4. So I can say, for question number for number 24, we can say between negative 5 and negative 6. And the other one, again, between a positive and negatives, we could say between, and when you're listing the answers here, you're saying the x values, between x equals negative 4 and x equals negative 3. Okay, let's try question number 25. Again, locate, ignore the x's, but locate the f of x or the y-axis. Basically focus on the second one down here. And anything between a positive and negative, so I can see right there. So 0 should be right there. So we can say between x equals 0 and x equals 1. And I can also see that here. Between negative 3 and, whoops, did you guys see my mistake? Between 2 and 3. Alright, number 26, again, just focus there at the bottom there. You're looking for a change between positive and negative. Here is my change between positive and negative, so we can say between, this one's tricky, negative 3 and 0. And over here, so I can say between 6 and 9. Okay? Directions for question number 27 to 32, skip 3 problems, use the table to solve each equation. If the exact roots cannot be found, approximate the roots to the nearest hundredth. Okay, so now let's just get a table of values. So negative 3x squared plus 3, let me bring this up. So let's put that in here. I think it was 3 negative, whoops, 3x squared plus 3. Okay, so let's just go to a graph first. Okay, so you can already tell what, you don't even need a table of values, but you already know the answers is negative 1 and 1. Now, you can also use the trace function. Now, the nice thing about with my iPad is that I can just put my finger on it, and I'm looking for the word 0. And it kind of locks in for you at negative 1 and at 1. For the table, let's go to second table set, and let's start at a whole number and start at a whole number. Second table. And so then I'm looking for those numbers. There's 1, 0, and -1, 0. Okay, let's go ahead and try number 28. So let's go back to our calculator. Y equals, clear it out, x squared minus 3x. So again, if you get an error mistake, sometimes that's a negative sign. I'll show you guys. Some calculators allow it, some don't. Okay, mine, what did I do? That was bad. Let's try minus, see what happens. There it goes, see? Okay, so I can already tell the answers, double check why they call this tracing. Okay, so that's essentially +1 and a +2. Let's look at the table of values to make sure. Yeah, see that? 1 and 2. So x equals 1, x equals 2. And if you want to write that together, that's essentially x equals 1, 2. Right. All right, 29. Don't be scared, you have a fraction here. Okay, so to get a fraction, a student taught me this, you can press y, alpha and then y equals. Alpha, y equals. And there it says ND, numerator and denominator. So then there I can type in 1, go down, 2. Okay, I forgot the it's negative sign, so you can press left, 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 left. And to move over there, now you can type in x squared plus x plus 5/2. Alpha y equals 5 down 2. Now, pay attention, let's go right. Okay. Graph to get a visual. Okay, I can already tell they're not going to be whole numbers. Can you see those two numbers there? So I know it's around -1.5 and 3.5. You can write that down. At least we know where it's kind of at. So now I'm going to use my table. Second table set. We said it was near -1.5. And let's just do 0.1s now. So what happens? Okay, right there. You see it? If you wanted to, you can do second table set and do another 0.01. Let's see what happens. Okay. Okay, I know it's around -1.44. Let's write that down. And we haven't used this, but you can use this symbol. Is there squiggly equal signs? That means approximate. And the second one was around 3.5. So go to second table set. Let's just type in 3.5. Go to table. And you're looking for the number to change from negative to positive. And I see that around 3.44, approximately 3.44. And something you'll notice too is that a lot of your estimates will actually be very close to each other in terms of the numbers. Okay, let's try question number 30. Let's punch it in. Y equals x squared minus 2x minus 2. Remember, the math operations are on the blue on the far bottom right on my screen. And the negative sign is to the left of enter, which is in white. I'm going to press graph to give an estimate. You can see that these numbers aren't going through whole numbers, if that makes sense. And we'll use the trace function, but this one is just the best what we have so far. But again, you can have just done something like that and get the answer. But we're trying to use the table of values. That's the point. So I have it in there. Oh, we forgot what our answers were. How about 2.75 and negative 0.75? Let's try 2.75. And pretty close, right? I changed it to 0.01 once I was really close. If you're not close, you can do 0.1s. But there it tells me my x value around 2.74. 2.74. And the other one was, second table set was around negative 0.75. And now I'm going to press table. Okay, so negative 0.73, between negative 0.73 and negative 0.74. Just say negative 0.73. Okay, let's go ahead and try question number 31. Y equals negative x squared plus 2x plus 4. I'm going to graph it to give an idea. You see those numbers are around negative 1.25 and 3.25, because between $3 and $3.50 is $3.25. Does that make sense? Negative 1.25. Let's try it. Second table set, negative 1.25. Table. Okay, there's this change between negatives and positives, so that's around negative 1.24. I forgot. Let's try 3.25. Second, get the table set. Now press table. And there's the negative and positive between around 3.23 and 3.24. And let's try number 32. Press Y equals, press clear. I'm going to press 2. Let's do my trick. XX minus 12x plus 17. Graph it to give yourself a visual. This is really, right? This is awesome because it's really telling you where it's at. 2.3. Let's try around 2.3. So second table set, 2.3 table, and we were pretty spot on, right? Between the negatives and positives there, 0.0082 and negative 0.02, I have around 2.29, 2.29. And the other one was 3.7. Dope. 3.7, 3.7. And right on the money. 3.7, 3.71. And that's how we used the calculator and using the table specifically to get to estimate our roots. All right, math lovers, let's go to 1.25, solving by using a calculator. We're going to be doing some word problems. And the first thing we're going to do is the same thing. We're going to put this into our calculator, use calculator, and use y equals the button. And note that it has to be set equal to 0. Set equal to 0. Basically, your calculator can only accept standard, it can accept standard form, vertex form, vector form, we're going to learn later on, but it has to be 0, set equal to 0. Okay? Second thing you're going to do is just press the word graph. Okay, third, this is where it's a little bit different. We're going to look for the button on there called calculate. We're going to look for a button on there called calculate. And once we press that button, we're going to look for the word 0. Remember, at 0 is where it crosses the x-axis. Okay, that's a 0. So what that is, it's an x value, but the y value is 0. Does that make sense? Okay. Fourth, you're going to do these boundaries. Boundaries. So when it says left boundary, that just means on the left side on the x-axis. Okay? And the right boundary, well, what do you think that means? Yeah, the right side of coming from the right side of the graph. Okay? Let's go ahead and try this problem here. A punter, well, I know it, I missed one. Step 0, it's kind of weird, I always call these step zeros, is draw a picture. Draw a picture, because it conceptualizes what you're doing. Okay, a kicker punts a football. The height of the ball after t seconds is solved by h of t equals negative 16 t squared plus 50t plus h0, where h0 is the initial height. Okay, let's do a couple things here. You're basically trying to solve for t. And what does t represent? It represents I'm now saddened by my non-straight lines, because I can do that. Okay, the x-axis is really represents t, and t represents time. So really that's what you're trying to solve for, measured in seconds. Now, when you get these word problems, you're confused, you can always do like, you can change h of t to be f of x, like function notation, or super simple, you can make it like a y. Now, I like to make my t's capital so they're not confused by my x's, or plus signs. And I erased it because I wanted to show you that you can also make this something like this. This is sometimes a little bit more palatable among students. Now, what is that h0 in this problem? It says if the ball is 1.5 feet above the ground when it meets the punter's foot. So initial height, HO, is basically where it starts. So when the punter drops it, it's at 1.5. So basically H0 is equal to 1.5. This here is representing by plus 1.5. Okay, so that's the equation we have to graph. Couple other things if you just want to note. Remember, this is y, and that's the same thing as height. measured in feet. And you're going to have some guy, you know, kick something, I don't know, 1.5, and then your graph. And we're basically looking for this yellow dot and that green dot. Okay, so let's just put in our calculator and see what happens. And the great thing about this calculator is, you know, you can just pinch and zoom in. I mean, didn't have that when I was in school 50 years ago. All right, negative 16. Okay, this is why I told you to change from x, because there's no t. Don't use t, just use x. Negative 16x squared plus 50x. Okay, we said plus 1.5. Okay, let's take a look at the graph here. Alrighty, there's my graph. I'm pinching and zooming, I'm doing all these things. Okay, there's my graph. Okay, alright, what we said was look for the word calculate. So, if you put your, on mine, I had to touch the graph, and calc is on the bottom. Okay, so it says left bound, and I'm going to focus on the one that is between 3 and 3.5. And that's actually the perfect numbers to put what's on the left boundary. So 3, my right boundary is 3.5. I don't know what TOL stands for. Well, once I clicked on TOL, my 0, it tells me is at 3.15. And that's the answer, 3.15. Now, you could have just pressed, there's another one you can do on the regular graph calculator, just press trace, and then you can move your finger, you know, on the graph, right? Does that make sense? Isn't this kind of cool? Like, okay, there is, okay, so this one doesn't make sense. Negative 0.02 feet in time. You can't go back in time. And take a look at this, you know, the football's going up. And if you look at the white value, that's how high the ball's going, and it peaks out around, and it tells you at 40.56. Okay, but the one we wanted was time, right? And he kicks the ball and it hangs in the air at 3.15. Let's write that. It takes 3.15 seconds for the ball to hit the ground. Okay? And the questions below, you're going to have to do a little bit more work. And what I mean by that is you're going to have to do a little bit more substituting. Okay? So go ahead and pick one, and if you want to see them do it together, let's do it together. Questions 33 to 34, skip one problem. Physics, use the formula h of t equals negative 16t squared. So I'm just going to copy down that formula. Plus VOT plus HO. Now it's going to tell you HT is the height of the object in feet. VO is the object's initial velocity in feet per second. I don't know. It's a simpler way to say it, but speed. T is the time in seconds, and HO is the initial height, which we already talked about. The object, round to the nearest 10. Mela throws a baseball. So let's draw a picture. That was something that's super helpful. Just copy something what we did before, right? Okay, so first thing, throws a baseball with initial upward velocity of 32 feet per second. Don't worry about 32 feet per second, but initial velocity is VO. So that number is 32. The baseball is released from Mela's hand at a height of 4 feet. Okay, released at 4 feet is the initial height, the starting height. So this one is going to represent +4. Use a graphing calculator to figure out how long it will take before it hits the ground. So let's just do calculator friendly or calculator ready equation. I'm going to change that to y because that's what the calculator has. Same thing with t's, I'm going to put as x's. And that's the one I'm going to be putting into the calculator. Negative 16x squared plus 32x plus 4. I'm just going to graph and give myself visual. Okay, I'm going to focus on over here. So that graph is between 2.0 and 2.2, so I'm going to click on the graph. I could just use my finger and tap it, but this is better because this is more universal. It's calculating what you're coming in from the left side. The left side of your graph is going to be from at 2.0. And the right side is going to be at 2.2. Bum! 2.12. 2.12. It will take 2.12 seconds for the ball to reach the ground, to hit the ground. So this is 2.12, that number doesn't matter. This is time measured in seconds, you always label. This is height measured in feet. And so the path of the ball that goes like this, well, starting here at 4, and this is going to take 2 seconds. All right, let's try question number 34. I'm going to copy the formula they have. And a punter kicks a football. So let's go ahead and draw a picture. This doesn't look really straight, does it? With an upward velocity of 60 feet. Velocity is this one, VO. So that would be 60. The ball is 2 feet above the ground. Okay, so that is we learned above is the initial or starting point. So that would be +2. They basically want to know what t is. So let's go ahead and fill this in. And remember, we'll just change it to friendly y's. Negative 16x squared plus 60 plus 2. Let's put it in. Negative 16x squared plus 60x plus 2. Let's go to graph. Okay, so it looks like that number is between 3.5 and 4, so I'm going to click on the graph. Then I can actually press the button calculate. We said it was between 3.5. Oops. Go up. There it is. And 4. And there it tells me my answer is x equals 3.78 in the top. Okay, now, you see where the y, it doesn't say actually 0, but that number, if you did scientific notation, would be like 0.0000000028421. So it's like literally 0. But 3.78 would be your answer. So the graph goes like that. What did I say? 3.78. That's what I said. It will take approximately 3.87 seconds for the ball to hit the ground. Okay, so initial height of 2. This value over here is not important because time cannot go. Time measured in seconds. And this one over here on the y-axis, which we ran out of space, is our height measured in feet. Okay. And that is lesson, and you just stop and don't do those. This is lesson 1.2. We'll see you guys later. Bye.
Shout out to Mr. Eng for being the best math teacher that there is. And math is easy.